like to thank Mary Lee, Phoenix, and Sonia for the opportunity to speak with you today. My name is Raman Muthusamy. I'm the Medical Director of Endoscopy at UCLA Health, and I'm going to talk to you about efficient endoscopic practice, climate burden, and single-use devices. So the environmental impact of GI endoscopy is substantial. That can include things we traditionally think about like endoscopes, as well as endoscopy accessories, but also the building that we do it in, the infrastructure, the travel needs of both ourselves and our patients, educational issues related to attending and going to these courses, medications that we use during the procedure, miscellaneous waste such as personal protective equipment, as well as administrative issues related to billing and document reporting. So the core principles of environmental sustainability in endoscopy are a reduction in unnecessary endoscopy as well as in equipment used in an individual endoscopy. In those cases where equipment use is necessary, we try to reuse those products whenever feasible and safe. And then finally, when reuse is not possible, the waste generated should be recycled as much as possible. And several documents have provided some guidance about this issue of sustainability in endoscopy as listed here. So we know endoscopy has a substantial environmental impact. The current annual U.S. endoscopy waste is estimated to be 38,000 metric tons, which is the equivalent of 25,000 passenger cars and would cover 107 soccer fields to about 1 meter or 3 feet in depth. So the goal, as I mentioned, is to reduce low-value procedures, which can be due to an incorrect indication or repetition of a prior procedure because we have poor transfer of records, perhaps defensive medicine, or perhaps a lack of good non-endoscopic options. And then the second part of that is to minimize waste per procedure, and that could be minimizing the use of single-use devices, sort of being more conservative with water, using reusable PPE, reducing travel, minimizing detergents, batch shipping to reduce packaging, and so forth. So the sources of environmental impact from endoscopy include carbon dioxide emissions and sort of as development of greenhouse gases. And this involves production of items, which has an impact, as well as transporting those items to the unit, and then as well as energy consumed by the performance of endoscopy in the unit. It also includes sort of standard mechanical waste as well as chemical waste, which often results from reprocessing. So this is an article looking at a couple of centers. One was a lower volume endoscopy unit, and the other was a higher volume endoscopy unit. And as you can see here, the mass in kilograms per case was about 2.1 kilograms of waste per case, a little bit higher in the high volume endoscopy center, and about 64% of this was direct landfill, 28% biohazard, only 9% recycling, and interesting, none of that came from the low volume center. So again, this gives us some idea of just the sheer amount, nearly 5 pounds per case. This is sort of aggregating the U.S. endoscopic waste here into the tons, so you can see what it is currently with all reusable endoscopes. And the concern has been that if we start moving towards single-use devices, particularly colonoscopes and duodenoscopes, that sort of overall waste would increase by 25%, and that would increase by 40% if all scopes went to single use. And you can see a large percent of this is landfill and biohazard, some recyclable, and then you can see as we move to a larger percentage of single use, the scopes themselves create more waste. This is another study from a single endoscopy unit at a VA in Kansas City looking at 450 procedures over 2 months from the point of entry to discharge. And it appears to be that the unit was doing about 14 procedures a day. And so obviously this would be typically larger numbers, most likely for larger units in terms of total amounts. They found that there were about 2.2 kilograms of waste per procedure went to the landfill. About 20% of the waste was potentially recyclable, which would save about 60 kilograms of waste per every 100 procedures. They also found that reprocessing costed about 1,385 gallons of liquid waste per 1,000 procedures. So again, on a per 100 procedure basis, about 303 kilograms. They found direct landfill waste was 219, and then they ended up with 72.8 kilograms of biohazard, less for sharps, recyclable about 60 kilograms, and so forth. So if you look at this in terms of a carbon footprint and carbon emissions here, you can see the landfill waste was annually about 2 football fields a foot tall for this endo unit. The wastewater use could provide an average family's water needs for 2 months, and the energy consumption for this unit, would allow for every 100 procedures would allow you to drive a car 1,200 miles. The total carbon footprint for this, again, would be about equal to 169 gallons of gas consumed. And as mentioned, they found 20% potential for recycling. The slide highlights sort of the life cycle of an endoscope. Obviously, you have to make the device, then you take the resources, you manufacture it, you then transport it to where it's going to be used. You use it for procedures, and then eventually, you reprocess it for a period of time, and then eventually the disposal, you dispose of it. Now, that's sort of what we see for reusable devices. For a single-use device, the total amount of resources and manufacturing will be significantly higher, as will transportation, because you have to transfer a scope for each case. Probably the per intra-procedure will probably be similar. Obviously, there's no reprocessing with the single use, but significantly more waste. So this sort of just highlights sort of some of the trade-offs. So you save some with single use here, but obviously there's significant impact elsewhere along this cycle. But we need to remember that at present, single-use devices are primarily for duodenoscopes. And as you can see from the original study that I presented earlier, that the total annual waste from the United States involves 18 million endoscopies, of which 11 million are colonoscopies, 6.8 million upper endoscopies, and only 170,000 are ERCPs. So again, a small fraction of this really accounts for this total amount of waste that covers the soccer field up to a meter, or is equivalent to the 25,000 passenger cars. So again, there's a variety of types of waste in endoscopy. You can see that some things can be recycled. Some of these are accessories. Some are sort of domestic kind of waste, which can be really associated with just paper, food, other sorts of things from the endo unit, break room. There's a lot of waste associated with the single-use or disposable procedural components. And then, of course, there's the sharps. And again, these are created and just potentially disposed of at either the pre, peri, or post-procedure stages of the procedure. So there is an opportunity to recycle. I told you the VA study found a 20% recycle rate. This is another study that actually found that it could be even higher, primarily due to recycling of plastic, but also paper and cardboard, metal and fabric, and this really suggested it may be as high as 48% of the waste can be recycled. These are some practical tips for a green endoscopy unit. It starts really for sort of developing a recycling culture and having individuals who are green champions, but you can sort of do this a variety of ways in terms of minimizing histopathology, avoiding and teaching and training and sort of best methods for minimizing use of resources and reducing waste, going digital as much as possible, maximizing procedure appropriateness, minimizing the use of paper, using renewable energy sources, responsible purchasing, which could potentially minimize the number of shipments that need to be made, and improvements in reprocessing and decontamination that will be more energy efficient. We can also make individual changes ourselves. This is a little diagram from the ESGE about the eco-endoscopist, someone who sort of uses reusable gowns and PPE. They use no plastic cups, reusable cups, shoes. They appropriately recycle and segregate waste, and then even other things that we can do in terms of how we get to work in how we obtain our training, perhaps virtually rather than traveling to meetings, reducing energy waste, and perhaps even seeing our patients through an increasing use of telemedicine. So areas for future research in green endoscopy, including looking at multi-center trials that may evaluate the performance of non-endoscopic technologies and sort of non-endoscopic pathways to achieve care that can reduce environmental impact. We can look at the assessment of hotspot areas in the process of endoscopic procedures and design better accessories and reduce the overall amount of waste and perhaps improve recyclability and biodegradability. Compare sort of what's the impact of single-use devices and how to minimize their environmental impact while maintaining their infection control benefits. And perhaps AI can help reduce with some of the histology needs. And again, post-procedure, again, there's a lot of work that can be done in terms of improving our reprocessing to minimize the environmental impact there. And then also in general, sort of looking at things like the use of sterile water, the PPE protocols, and then look at even ways to educate in order to minimize the amount of educational expense and resources that are used as well. So how do you get started individually? You can assemble a green endoscopy team, understand your baseline processes and problems, choose an individual task or alternative practice to implement, and then assess your intervention and refine, reiterate, and revise as needed. And you can share your data with others and gain ideas from them as well through a sort of process of constant self-improvement. And again, going back to the 3 R's, reduce, reuse, and recycle, this paper nicely summarizes some of the many things that you can do, from curbing unnecessary procedures to purchasing in bulk, to reducing video storage, even to minimizing patient travel and so forth. You can also reuse as much as possible cups and trays, consider an EGD and for both a EGD and a flex when those are being done. Perhaps distributing solutions more centrally. And then again, when you are creating waste, to try to focus on recycling whatever is possible. Okay, so with that, I'm going to transition to single-use devices. So on one hand, we have this impact of trying to minimize our environmental impact, but at the same time, we also want to maintain patient safety and have adequate infection control. So endoscope associations have been reported, but they're not new. Initially, this was for salmonella in the 70s and 80s. We had Pseudomonas in the 80s. We had some TB and atypical mycobacterial from bronchoscopy as well. Hepatitis B, H. pylori, and hepatitis C have been reported, but not HIV. And then in 2000s, we started seeing the more concerning multi-drug resistant organisms. Until recent outbreaks, all cases of endoscope cross-contamination have been associated with major breaches in cleaning protocols. This is a summary of the duodenoscope-related transmitted infections, which really began in the early 2010, initially in Europe and then in the US. More than 45 sites and 350 patients have been infected. This likely represents underreporting, given it's hard to prove these things, and it's been seen with all manufacturer types. This really crested in 2015. And we have seen a significant decline due to improved processes since then, but there are still outbreaks reported, and there are still reports to the FDA of patient deaths that occur. This is a post-market surveillance study that was commissioned by the FDA to see how often contamination was seen after high-level disinfection of duodenoscopes. And while they expected a 0.4% rate, they actually found something closer to 5%, which is about 13 times what they expected. They also found in a human factor study numerous cases where there were incorrect steps in terms of pre-cleaning. In many cases, in fact, more than half the steps would even be missed on some devices. We know that part of the problem is the duodenoscope tip, which is very complicated. It has this elevator with sort of sanctuary behind the elevator, an elevator cable, sort of this elevator V-notch, hinge mechanism, divots on the scope, and these can all be sources of infection. A duodenoscope heat map here sees that there is evidence of not just the tip, but also it can occur in the channel And so this is one of the challenges for the current trend towards disposable caps and elevators, in that while they may present some improvement, there may be residual risk in the channels. We also see mechanical damage to the duodenoscopes. You can see a variety of damage occurs here, and we probably need to have a more rigorous process of sending scopes back for routine maintenance rather than for waiting them to have a failure or some imperfection that is visible. And here's some more channel damage here that you can see on the inside, scratches to the channel, and you can see some areas of damage within the scopes that are not often appreciated initially. So this is the reprocessing cycle, which again, every blue arrow is a reprocessing step. Every green arrow with all the things next to it are areas where something can go wrong. And the little sidebar here is related to the step if you happen to use ethylene oxide sterilization. So the point being here, there's lots of opportunities both during the reprocessing cycle and even during the storage area with moisture and so forth, where contamination can occur. There's a variety of single-use duodenoscopes that are being developed. 2 are currently available on the market, shown here. But the reusable duodenoscope makers are now getting into this as well, so there'll be even more on the market shortly. These devices here are very similar to sort of the commonly used reusable devices, the single-use devices. Here are the 2 commercially available. One is in the United States. You can see in many areas they're near exact in terms of the physical performance characteristics. Single-use devices have, of course, the advantage of no issue with reprocessing inadequacy. They potentially could provide stable inventory. They could be made lighter and have an ergonomic advantage, and perhaps even modified in ways uniquely to have right or left-handed versions or knobs of different sizes. But their cons are the cost, perhaps quality, potential issues with durability during a case, and of course, medical waste and its impact on the environment. Here's the data on efficacy, comparability, and safety of these devices. And you can see that in most of these studies, the results are very similar. We have over 400 cases now that have been published. Success rates 91 to 97%, and the satisfaction of the endoscopist and adverse events rates observed were comparable to reusable devices. What about the environmental impact of single-use devices? A study looked at single-use release of carbon dioxide and found that it was 24 to 47 times greater than reusable scopes. Much of this comes from manufacturing, which accounted for about 90 to 95% of the greenhouse emissions. They found that they estimated at 4% of electronics composition in manufacturing because most of the manufacturing impacts come from the electronics. The second highest contributor is the disposal, of course, which generates about nearly 2 kilograms of CO2 equivalent per procedure and accounts for 3 to 5% of the greenhouse emissions. And as quoted by that earlier paper, they estimated that conversion to all single-use scopes increased waste mass by 40%. There are some points to consider, however. The analyses didn't account for the fact that these devices typically are recyclable. They use the ureteroscope as a surrogate device, and it turns out the actual electronic component in the duodenoscopes is 2%, not 4%, as it is in the ureteroscope. And even if 100% conversion to single-use duodenoscopes occurred, it would release 18 million kilograms of carbon dioxide, which is equal to the annual emissions of 3,945 passenger cars, but one has to realize that we have nearly 300 million cars in the United States. And it would be equivalent to eliminating a single round-trip New York to LA flight with 200 passengers every day. And we must remind ourselves there are 5,670 domestic flights in the U.S. and over 100,000 flights globally. And of course, I don't think that there's any anticipation to moving to all single-use duodenoscopes at this time. Advantages of single-use devices are that it could preserve or expand the site of service at low-volume centers and small hospitals where complex reprocessing may not be available. There may be ergonomic advantages, and I think we've seen an increase in the rate of innovation. For example, with one of the single-use duodenoscopes, the original project was pitched in 17, animal cases done in 18, first human cases in 19, and 3 commercial iterations have already occurred. So we're seeing model updates more like an iPhone rather than a car. We can also see new specialty scopes that are thinner, longer, rotatable, or even have dual cameras, forward and side viewing, that could facilitate the performance of complex procedures. When should you use single-use devices? Well, I think that you can use them to facilitate logistics or operations, such as at weekend or at night, backup fleet on busy days, and as I mentioned, at low-volume off-site centers. You certainly could use it to protect the fleet in a patient with a known multi-drug organism, but they're pretty rare. You could use it in critically ill patients who might not be able to withstand a scope-acquired infection, such as transplant patients, ICU patients on pressor supports, or hospitalized patients in general. And finally, you could use it in procedures that potentially are at higher risk for bacteremia, such as cholangioscopy, biliary RFA, or a stent placement. It's my belief, given the knowledge and existence of this option, patients will increasingly request it when feasible. The bottom line is that the cost to perform ERCP is going to rise. There's going to be new technologies, new scopes, adapters, reprocessing technologies, cleaning techniques and accessories, more staff training and monitoring, more tests for validation of reprocessing adequacy, and then likely the incorporation of some single-use devices. Where are we now with single-use duodenoscopes? Well, I sort of joked that initially when this project was pitched, it was felt to be impossible. Subsequently, there was skepticism it wouldn't be any good. Once it appeared that it was feasible, people were concerned about the cost. And then subsequently now we're sort of in the phase it's going to destroy the environment. And ultimately the question is, will there be acceptance, and so which situations? So in summary, the environmental impact of endoscopy is substantial, and we should look for ways to reduce unnecessary low-volume endoscopy whenever possible, reuse equipment when safe and feasible, and recycle waste, again, as whenever it's possible. The potential for duodenoscope-transmitted infections persists, but process improvements have led to reduced rates of reported outbreaks. Single-use duodenoscopes have been shown to be effective in a variety of settings and studies. Further study on optimal indications for these devices is warranted, but given overall endoscopy waste, these devices will have limited impact compared to waste generation from standard endoscopic procedures. Again, this is specifically the single-use duodenoscopes. And finally, future advancements are needed to make endoscope reprocessing more efficient and environmentally friendly. And I think it's important for us to remember that patient safety and environmental sustainability should not need to be at odds with each other. We should aim to try to preserve both as we move forward with our research and development.